So in the fifth question, we are using the dataset RDChem. In this dataset, RD denotes annual expenditures on research and development, and sales denote annual sales. Both are in millions of dollars. So in this question, we are being asked to write down a model that implies a constant elasticity between RD and sales. Constant elasticity implies that we have to take natural logarithm of both the variables. And in the second part, it is asking to estimate the model using the data in RDChem and what is the estimated elasticity of RD with respect to sales. So let's begin. First, load the dataset RDChem equals to woo.data RDChem, and then display the first few rows of the dataset by using the command print rdchem.head, and these are the column names in the dataset. Now, since the question says constant elasticity, so we have to estimate a log model. So in the dataset, you can see there is a column by RD and by sales, and in the dataset it is provided log of both these columns. See this, LRD is logarithm of RD and L sales is logarithm of sales. So create a model by the name of model equals to smf.ols. In the bracket, type formula equals to LRD is being explained by L sales, that is log of RD is the y variable and log of sales is the x variable, and the dataset name is rdchem.fit function, and then print the results by typing the command print model.summary. So this will give you the following result in the right hand side of the screen. Now we have to extract the elasticity, that is the coefficient on this L sales variable. So type elasticity equals to model.params. In the square bracket, type L sales. And now we have to print the estimated equation. For this, we have to create a variable by the name of intercept equals to model.params, and then in the square bracket intercept, and you can see on the right hand side the estimated equation is as follows: log RD equals to minus 4.1047, that is the intercept, and plus 1.0757 into log sales. And what is the interpretation of this elasticity? It means that a 1% increase in sales is associated with a 1.08% increase in R&D spending. So whenever we take logarithm of both the variables y variable and x variable, the interpretation is expressed in percentage terms. So that's why we here say that a 1% increase in sales is associated with a 1.08% increase in R&D spending. So we are done with this question. Let's start with the next question. Question number 6. So in this question, we are using the dataset MEEP 93. We want to explore the relationship between the maths pass rate and spending per student. It says, do you think each additional dollar spent has the same effect on the pass rate, or does a diminishing effect seem more appropriate? For this, we have to work out the relation between pass rate and expenditure, and we can do this by correlation and regression analysis. Now in the second part, it says in the population model, this is the population model, math 10 is being explained by logarithm of expenditure. Argue that B1 divided by 10, it is the coefficient on log expend, divided by 10 is a percentage point change in math 10. Okay, so let's begin. First, load the data set by creating the data frame MEEP equals to woo.data in the bracket MEEP 93, and display the first few rows of the data set by typing the command print MEEP.head. This will give you the following result in the right hand side of the screen, and these are the column names. Now first it is asking whether there is a positive relationship between expenditure and maths pass rate, or there is a diminishing effect. So first we will calculate the correlation between these two variables by typing the dataset name and then select the columns math 10 and expend, and then type core function dot CORR, and then type dot ILOC in the square bracket 0, 1. This specific command will give us the specific correlation between these two variables. If I do not type this command ILOC, it will give us the whole correlation matrix, and we do not want the whole correlation matrix. We just want the value specific for this math10 and expand variable. So ILOC 0.0, 1 give us the value present in the first row, second column. So what is the correlation? Correlation is 0.18. The correlation is positive. Okay, these are positively related with each other. That is, more expenditure leads to better mathematics pass rate. We can also look at the regression analysis for this. Type model expand equals to smf.ols. In the formula, math10 is being explained by expand. Okay, expand is the x variable, math10 is the y variable, and the data is meep.fit. And then type the summary for this model expand.summary. So look at the coefficient on expand variable, 0.0025. So this is also positive. Okay. However, it is more realistic to assume a diminishing effect of spending on the math pass rate, because initial spending can improve essential resources such as teacher quality, classroom materials, and student support, which likely have a strong impact on performance. However, beyond a certain level of expenditure, the marginal benefit of additional spending decreases, leading to diminishing returns. This economic intuition supports using the log of spending in the regression model rather than the raw expenditure level. So in the second part of the question, we are taking the log of expend. Create a new column, log underscore expend equals to np.log round bracket the dataset name, and in the square bracket select the expand column, because we are taking the natural logarithm of this column. Now estimate the model, math10 being explained by log expand. So type the model name, create a model name, model equals to smf.ols. In the bracket type formula equals to math10 tilde log underscore expand, and the dataset is meep.fit. Now let's look at the results by typing model.summary. So on the right hand side, you can see the summary of regression result. The intercept in this model is minus 69.34, and the coefficient on log expand is 11.16. Extract the estimated of coefficient, that is beta 1, by typing beta 1 equals to model.params in the square bracket log expand, log underscore expand. Now we have to compute the effect of a 10% increase in spending. So create a new variable, effect underscore 10% underscore increase equals to beta 1 divided by 10, and the intercept is model.params in the square bracket intercept. So estimated equation is math10 equals to minus 69.34 plus 11.16 into log expand. So what is the interpretation of this value 11.16? Estimated effect of a 10% increase in spending leads to 1.12 percentage points increase in mathematics pass rate. Okay, and what is the maximum? And it also says is mathematics 10 of predicted mathematics pass rate greater than 100 is a mathematical possibility. However, it is not a practical possibility. So the question asks to check whether there is any predicted mathematics pass rate that is greater than 100. For this, we can use this value, create a new variable by the name of max underscore math10 equals to model.predict, and then type the dataset name meep, then dot max function. So maximum predicted mathematics pass rate is 30.15. So the mathematics pass rate being greater than 100 is not an issue in our data set. So we are done with this question. Let's see the next question. In the seventh question, we are using the dataset charity. And in this dataset, in the first part, it asks what is the average gift in the sample of 4,268 people, and the gift value is given in Dutch guilders. and what percentage of people gave no gift, what is the average mailings per year, what are the minimum and maximum values, and in the third part, estimate the model gift variable being explained by mails year by OLS, and then we have to interpret the slope coefficient, and then we in the last part of this question we have to find out what is the smallest predicted charitable contribution in the sample. Okay, so first load the data set charity equals to woo.data in the bracket charity, and then type then display first few rows of the dataset by typing print charity.head, and these are the column names in the dataset. So first we have to calculate average donation and percentage of zero donations. So create a variable average underscore gift equals to dataset name, and then select this column gift, and then type mean function, and percentage of zero donations, I create a new variable name zero underscore gift equals to round bracket charity, and in the and then select the column gift equals to 0 dot mean into 100 because we are looking at the percentage value. So average gift is 7.44 guilders, and percentage of people who gave no gift is 60%. Now we have to analyze mailings per year. We have to calculate average, minimum, and maximum of mails year. So simply select the dataset name and then select the column name mails year, and then type mean function mean, min, and max for minimum, maximum, and average value. So average mailings per year is 2.05, minimum mailings per year is 0.25, and maximum mailings per year is 3.5. Now we have to estimate the regression model gift equals to gift being explained by mails year. So create a model name by the name of model equals to smf.ols, and then in the bracket type formula gift tilde mails year. So gift is the y variable, mails year is the x variable, and then type the dataset name data equals to charity, and then dot fit function. Then type the regression results by typing print model.summary, and this is the summary of regression analysis. The coefficient on mails year is 2.64, that is mails year positively impacts gift value, and the intercept is 2.01. And now we can extract the coefficients to write the estimated equation. Intercept equal to model.params in the square bracket intercept, and slope equals to model.params, then type the mails year because we have used this variable, and r squared value is model.r squared. So the estimated equation is as follows: gift equals to 2.01 plus 2.64 into mails year, and r squared value is 0.01. R squared value is very less. Okay, as you can see, it is not even 0.05, so it is very less. So what is the interpretation of this coefficient? Each additional mailing increases the expected donation by 2.64 guilders. Okay, the charity gains 1.64 guilders per mailing on average. Now look at the last part of the question. It says find the smallest predicted contribution. So for this, we are going to use this, create a new variable by the name of min underscore mails equals to charity mails year. Select this column mails year, and then type mean function, min function, minimum, and then to find the predicted gift, minimum predicted gift, create a variable name by min underscore predicted underscore gift equals to intercept plus slope into this value, minimum mails value. So smallest predicted contribution is 2.67 guilders, and since minimum value is greater than 0, therefore the model does not predict zero donations, it always predicts a positive amounts. Okay, so we are done with this question, so let's move on to the next question. In the 8th question, we are not using any dataset. It is a technical question where we will generate some observations from distributions to verify some properties of OLS. So let's look at the question. The question in the first part, it says start by generating 500 observations on xi, that is the explanatory variable, from the uniform distribution with range 0 to 10. We are generating observations on uniform distribution so that we can be ensured that the values are evenly spread between a known range. Okay, so there is no biasness in the observations. Second, it says randomly generate 500 errors mu I from normal distribution with a mean of 0 and variance of 36. Therefore, standard deviation of 6. Now it says in this part, is the sample average of the mu I exactly 0, y or y not? What is the sample standard deviation of the mu I? Now in the third part, we have to generate the population regression model. Yi equals to 1, that is the intercept, plus 2xi, 2 is the slope or beta 1 coefficient, plus mu I, that is the error term, which is normally distributed over this range. Now it says in this part, what are your estimates of the intercept and slope? Are they equal to the population values in the above equation? Now in the fourth part, it says obtain the OLS residuals mu cap I, mu hat I, and verify that equation 2.60 holds. So this is equation 2.60 from the book, and there are two properties mentioned of OLS in this equation. First, it says that the sum of residuals should be equal to 0, and the sum of multiplication or product of explanatory variable and residual is equal to 0. The second property here, it means that the residuals are uncorrelated with the explanatory variables. Now in the fifth part, it says obtain the same quantities in equation 2.60 but use the errors mu I in place of the residuals. Errors, when we use the error term, it means that we are using the population term mu I, and when we say residuals, we are referring to this mu I cap, mu I hat. Now what do you conclude? Now in the last sixth part, it says repeat parts first, second and third with a new sample of data starting with generating the xi. Now what do you obtain for beta hat 0 and beta hat 1? Why are these different from what you obtain in part third? So let's begin. First, we have to generate observations on a uniform distribution. So first, create a random seed, np.random seed. In the bracket, type any number you like. I have typed 42. This command is just for the purpose of reproducibility. Okay, so I have typed here 42. You can type any other number. Then we have to observe the number of observation equal to 500. And now let's generate explanatory variables x equal to np.random.uniform starting from 0 to 10, and the number n here is number of observation. Now we have to calculate a sample mean and standard deviation of x. So create new variables mean underscore x, standard underscore x equals to np.mean x, comma np.std x. So mean of x here is 4.98 and standard deviation of x is 2.98. Now let's create errors from normal distribution. Mu equals to np.random.normal starting from 0, that is a mean of 0, comma standard deviation of 6 and 500 observations, that is n. Now let's calculate the mean and standard deviation of mu by typing the variable mean underscore mu, standard underscore mu equals to np.mean mu and then np.standard in the bracket mu. Now the mean of errors, that is mu I, is not exactly 0 because it is a random sample. Okay, so now let's create a population regression model. Y equals to 1, that is the intercept, plus 2 into x, that is the slope, or beta 1 is 2, plus mu. Now let's create a data frame. df equals to pd dot data frame, and in the data frame we are creating two columns, x and y. For the x column, assign x values, and for the y column, assign y values. Now let's estimate a OLS regression using formula. Model equals to smf.ols, formula equals to y tilde x and the data set is df.fit. Now let's look at the results of the model by typing the command print model.summary. So this is the regression result of our equation. Now let's extract the estimates. Beta 0 hat and beta 1 hat equals to model.params. Now estimated intercept beta 0 hat is 0.35 and the estimated slope is 2.13. You can see that in the population we had defined the intercept to be 1 and the slope to be 2, but these estimates differ a little bit from the population values. These estimates are close to the population values but not exactly equal due to sampling variability. Now let's verify the properties mentioned in equation 2.60. First, create a variable residuals equals to model.resid. Now let's take the sum of residuals by taking np.sum in the bracket residuals and the product and the sum of the product of explanatory variables and residuals. Create a new variable sum underscore x underscore residuals equals to np.sum in the bracket x multiplied by residuals. So sum of residuals is a number very close to 0. Okay, it is a scientific number, but it is very close to 0. As you can see that in the last digit is equal, it is written e raised to power minus 12. So it is almost 0. And sum of x multiplied by residuals is also 0. Now in the question it says that compute the same quantities using errors. Okay, errors are mentioned in the population regression model. So sum of errors is np.sum in the bracket mu, and sum of errors multiplied by explanatory variable is np.sum x multiplied by mu. So sum of errors is a positive number. You can see that it is something 2.28, and sum of sum of the product of errors and explanatory variables is also a positive number. So why it is not 0? The sums using mu are not exactly 0 because the true errors are not necessarily uncorrelated with x. Okay. So in the last part of the question, it says repeat first, second, and third with a new sample. So create a random sample by typing first np.random.seed, and in the bracket this time I'm taking the number 99. You can take any other different number you like. So create the new x variables, create new error terms, create new y, create new regression model, population regression model, create a new data frame, df underscore new equals to pd.data frame. And again, there are two columns, x and y. For the x column, assign x new values, and for the y column, assign y new values. Estimate the new model underscore new equals to smf.ols. And in the formula, y new tilde x new, and the data set is df underscore new and then dot fit, and extract the estimates beta 0 hat underscore new, beta 1 hat underscore new equals to model new parameters. So new estimated intercept is 1.60 and new estimated slope is 1.94. So these estimates differ from the first sample because of random variation in the data. And again, these are very close to the population values. Okay, so we are done with the question. Let's move on to the next question. Thanks for watching. If you found this helpful, don't forget to like the video and subscribe to the channel for more content like this. See you in the next one.